All right, so good afternoon, everyone. Thanks for joining us today. I know it's the last session, and it's been, well, pretty long day. There's been some really good sessions today. Hopefully you find this one useful. So I'm Jesus Alvarez. I'm over at IBM working on the DSX integration tools, integrating with a lot of the Hadoop components. And with me, I have Kat Petra, which is the PM of Ambari over at Hortonworks. And today we're going to be covering detecting real-time market manipulation across decentralized exchanges. So just to kind of get a feel for the room, how many of you have or have heard about Bitcoin or one of these other cryptocurrencies? OK, so pretty much everyone, right? You know, cryptocurrency has gone mainstream, right? My friends' grandmas have their own wallets. Everyone's talking about it now. You don't really get to have a morning cereal without actually seeing it on the news. It's gone mainstream. And one of the things that cryptocurrency going mainstream has done is it's essentially opened the doors for a lot of manipulation and people coming in here and creating these fake coins and essentially manipulating the market at the level of millions of dollars. So today we're actually going to be covering one specific type of exchange, which is a cryptocurrency exchange, which allows any user to actually go in there and log in without ever creating an account. That's one of the great things about these decentralized applications, that there is no real user sign-up. You just go and generate a wallet on your cell phone, and you are now a user on these exchanges. So we're going to be going into this one into quite a bit more detail.
Great. So what this talk is about, this talk is about using the open source Apache projects that we know and love, and actually analyzing the data logs that are going on through the blockchain. Just as importantly is what this talk is not about, which is how to build your own shitcoin. If you're interested in that, there's actually a couple dozen pretty good blogs on doing it, perhaps afterwards, but hopefully not. So we're going to start with the approach evolution, how we got here and why we're doing this. We're going to give you a brief overview on smart contracts, such that we can set the stage for what allows this type of manipulation. We're going to go through and explore the anatomy of volume-based market manipulation from a logical point of view, so we know what we're looking for. And then in the second half of the presentation, we're going to actually show you what it looks like to interact with the blockchain and bring the mythical blockchain to the data warehouse. And then last but not least, we're going to give you a little demo of our shitcoin detector and go through the Shitcoin of the Month awards. OK, so first things first. Why are we doing this and how we got here? We are actually doing this for fun. It's a bit of a hobby. We started doing this in about 2013, which is also when we started playing with the Apache Hadoop ecosystem. And so we started off actually just by building mining rigs. If you can kind of see the picture at the bottom left over there, this is how the first racks used to actually look like. It was mostly a bunch of graphics cards, mining transactions strapped together to a beverage cart from Costco with some hair ties attached hard drives. We did that for a while, up until the point where the PG&E bill for all of our mining operations was a little bit more than what we were getting in return. So at that point, we needed a bit of a new strategy. So the next step was arbitrage between these exchanges, high-frequency trading. That was pretty profitable for a while, up until we started getting some competition. So then it sort of became a battle of the trading bots, where what started out as a fun weekend project was more like, every weekend now we have to go improve the bot in order to be better than the other guys' bots. And that wasn't very fun anymore. The next space here in the middle, you can kind of see the evolution. The next phase was a lot of just looking at the charts, looking at screens, trying to understand what is actually going on in the background. And that is how we got the idea for knowing what to look for. Because a lot of this data science is not just looking and trying to detect patterns, but it's actually specifically knowing what are the types of patterns that are interesting to analyze. So at some point, it was actually quite interesting because we realized we can make more money off of detecting what the other bots are failing to do. So it wasn't just about predicting the market. It was actually an easier problem. It was predicting where the other developers are going to hard-code their bots and where their bots are going to fail. So that was a slightly more better approach. So that's what we're mostly doing nowadays. That and our environment has evolved over to mostly DigitalOcean and a couple slightly nicer nodes and a lot of analytics and, of course, doing our tax bits.
So before we actually go deep into this, let's take a look at blockchain 1.0, right? Bitcoin, when it first came out, it solved a real problem. It allowed one user to transfer an asset to another user securely. And more importantly, it was all happening with no central banks, no central servers really running this backend. And this was all possible because of the blockchain, this distributed ledger that allowed a transaction, sending a Bitcoin from one user to another. And all this transaction was being processed on people's graphics cards originally, just like we had that picture. Eventually, over the years, that evolved, and now there's specialized hardware called ASICs, which actually sits there and processes all these transactions. But one of the important things is that, for Bitcoin, you're not really doing, more than verifying transactions. You have all of this compute power sitting there at your disposal, but all you're doing is you're just verifying, that Bitcoin being sent from one user to another. And really what we're after, this is DataWorks, we're after the data. What logs get stored on the blockchain? And for Bitcoin, it's pretty simple, right? You get essentially, from Bob to Charlie, how many Bitcoins he sent, the block height. It's pretty simple data that gets stored, but you don't really get to do any computation on there. It's still pretty limited. And eventually that led over into what I consider, blockchain 2.0, right? The idea that you can now have some code, and one example that we're actually going to go into is Ethereum. In Ethereum, you can actually compile this code, which is written in Solidity programming language, and you're compiling it and actually storing the code itself on the blockchain. So now your applications, your programs actually live on the blockchain from the block that you deployed it. Anyone can come in here and interact with it. And for the folks in this room, it's a lot more like a RESTful interface, if you will, where now a contract is really the URL, and you're actually able to pass in input data to that smart contract. So some of the smart contracts that we end up seeing, what kind of use cases are in production today? And one of the really good use cases was currency exchanges. And the reason for that is that a currency exchange follows a certain pattern, right? You're trading one asset for another. At the end of it, that exchange should have happened, and it should have been stored on the public ledger, which is the blockchain. The input data is pretty simple, right? You have the token that you're buying, the amount, the price, who's doing the buying, who's doing the selling. All that input data is getting sent to the exchange's smart contract. And that works really well, right? There's a couple, fork deltas out there with over $1 billion in the smart contract. And I say $1 billion, and I almost want to put quotes around it because we're going to get to, how real is that billion. Some other applications that you end up seeing, crypto casinos. That also works really well because it's pretty simple, right? You're passing in two parameters. You're essentially rolling a random number generator. You're saying how much you actually want to allocate to that given bet. And then, when that block executes, you either end up making some 300-to-1 odds, or you end up losing your money. But it works really well because it's another smart contract which can be deployed. And for those of you in the room that were at the Trimble talk yesterday, they actually had a really good use case for their smart contract where they were using it for actually tracking agriculture and essentially wine. So they were capturing over 200 data points from the moment that a bottle was produced to the moment that the bottle was actually sold in a store. And all of this was captured in their smart contract. These 200 data sets were actually being stored and persisted to the blockchain, right? That input data is really what we're after. The ability to save that data on the blockchain reliably, and more importantly, immutable, right? You can't modify one of these blocks once it's created. Everything that gets posted is essentially there for everyone to go and see at some future time. And what I want to focus on here is the input data, right? The idea that the input data for the exchange can actually be completely different than the input data for a casino, and completely different than Trimble's use case yesterday. So let's go into a little bit more detail on one of these cryptocurrency exchanges. So here I actually have a screenshot of Fork Delta, which is that exchange that we're actually covering. And the way that this essentially works, this market manipulation, is that you'll get this person, and we'll just call him Charlie. And Charlie goes and he creates his own shitcoin, right? His SHT coin. And he'll create it with some ridiculous amount of available volume. He'll create it with, let's say, 100 billion tokens when he issues it. And creating the tokens is the easy part, right? That's what you're not here to learn, but there's guides that'll teach you how to do that in 20 minutes. That's not what we're after. But Charlie goes in there, he creates a coin, but more importantly, he creates an order on the order books. And the order that he creates is a buy order offering $13,000 at today's price of Ethereum. So he's actually willing to pay $13,000 for the own coin that he created. Nobody else holds this coin other than him at this point. Now, Charlie, because this is a smart contract and you can actually control the input data, can come in here and he can actually sell to himself, right? And that's kind of a crazy concept in exchanges, the idea that you're creating an order and you're saying that you want to buy something, and then you yourself are coming in here and selling to yourself. And if Charlie does this over and over again, he's creating all these orders for $13,000 time and time again. And the other kind of fine print that I have here is the exchange fees. Anytime that you actually execute a transaction on one of these exchanges, you're paying a certain percentage in fees. Now, the important thing here is that the fees are actually paid in the coin that he's buying. So when he's paying the fees in SHT coin. He's not really losing any real money. So every time that he's executing one of these orders, the exchange gains that 0.25%, but they're gaining a coin that's essentially worthless. And Charlie will do this over and over again, and eventually what ends up happening is, SHT, it'll be the highest volume on the exchange. Now, why is that important? Well, for new investors, they don't really know a lot of these cryptocurrencies, right? There's over 2,000 currencies on CoinMarketCap today. One of these new investors will log in, they'll see what the highest volume coin is, and for them, they think that's the next Bitcoin. They think, oh my god, this coin's on fire, it has the highest volume, this is going to be huge. And they'll go in there, they'll buy it, not knowing that all that volume was created by Charlie, or also Charlie.
OK, so finding Charlie is really a two-step process, and it starts with asking the right questions. We have to look for transactions whose buyer is equal to seller, which actually sounds simple enough. But there's still the second part, which says we have to get to the right data. And in order to do that, we have to actually parse the smart contract execution logs from the trade transaction in each block. So this is what we start with. We start with the block. A new block is acquired. Our client is figuring out the new block is acquired. But the block itself actually doesn't contain very interesting information. It just contains a list of transaction hashes. So for each one of these transaction hashes, we have to go in and make another call and actually get the transaction receipt. Now, the transaction receipt gets us one step further, but it's still not quite right, because this data payload here is basically a bunch of hex characters that we don't really know how to decode. So in order to make meaning out of this, we have to first filter out for all of the trades going into the EtherDelta address, which is how we know which contract ABI to apply. And after we have filtered out just the ones that are interesting, then we apply the contract ABI and figure out what does each method unhash to, such that we can get to this data. And what we're really after is specifically these fields, where the get address, which is the buyer address, is equal to the give address, which is the seller address.
Looks simple enough, right?
So bringing the mythical blockchain to the data warehouse. I will let you enjoy that for 1 second. So it turns out it's actually not mauve that has the most RAM. It is this light gray over here. So when it comes to bringing the blockchain to the data warehouse, we have to kind of start with the data warehouse. And that starts with building out the infrastructure itself. And it's not really about just building the infrastructure, because you also have to secure it. And if you don't secure it from the beginning, you're probably not going to end up securing it later. So one of the things that we force ourselves to do is all of this development with Kerberos turned on. So you can see here, this is my little environment. The top nodes over there are actually quite small. My Knox node, my IPA node, which is what I'm using to manage my central identity management. So that has a Kerberos and LDAP and so forth in it. And then you see here on the right-hand side, our little edge node. So what's interesting about this is that these nodes are actually only 2 gigs of RAM. They're really quite tiny, because the processing doesn't happen there. The processing happens in the Hadoop cluster itself. So you can actually see the sizes I'm using. These are actually 8 gig nodes for my masters. And what is actually doing the compute power are going to be my Kafka name nodes, data nodes, node managers data nodes, my little compute nodes. And this can be scaled out as much as you need. And my total cost of operations of ownership for this is actually about $430 a month, in case anyone's interested. OK, so this is quite a heavy slide. It's going to be a bit hard to follow, but all of the code, and including this architecture, is actually at a very high resolution over in GitHub. So you're welcome to go and find all of my posted notes later on. But just to kind of give you a high level of how we're running this. So everything is getting driven from our Jupyter notebook, which is shown up here on the top left. There are 4 notebooks that we are driving from. Only 3 have been implemented, and I will explain why in a second. So it starts with the first job, which is what its job is to connect over to the blockchain and get the initial blocks. So this is getting kicked off from Jupyter. We're going in through Livy. Livy is scheduling a job over in the cluster in the yarn nodes. That job actually happens to be running from the driver, which was a bit of a surprise for us. But that is how, I guess, the Spark Kafka connector runs. So that is it. So from here, this essentially acts as the controller. So we're requesting in each block from Parity. Parity is the client that we're using to synchronize the data from the blockchain. And then we are returning a block. So now, for each block, we are actually producing it over to an @logs topic just to keep track of where we are. For each one of these blocks, we are sending it over to Kafka. And then we are bringing in the second notebook, which is our ED processor. And this one is running over here. It's consuming from the Kafka topic before. And then for every one of those blocks, it's getting transaction receipts. Right? So we are looking at the contract API. We're going to filter out for the EtherDelta trades, and then we're going to look for the transactions where get is equal to give. The third notebook here is actually quite interesting. So in the original plan, we were going to put everything to Twitter, but there were a couple problems with it. The first one is that we had a lot of volume. This is actually happening a couple hundred times a day. And the second problem is that after we started looking at the data, we realized it's actually quite risky, because we are finding some pretty interesting manipulations, and maybe those people would not appreciate it. So if you do want to have the Twitter bot, it is very easy to just take the self-pumps topic and consume from it, but that is left as an exercise to you. The last notebook here is our remote @logs data warehouse. So here we are kicking off one more notebook. It's running Spark. It's actually running in distributed Spark, so here we see executors. And what we're doing is picking up the Kafka logs into a data frame, such that we can do Spark SQL on top of it and figure out who is manipulating this the most. You want to talk a bit about virtual environments? Or?
Yeah, so one of the kind of neat things on this architecture was when we created that first Kafka topic, the one that has all the event logs, we're only really doing this for this demo for one smart contract, but there's thousands of smart contracts out there. Right? So this really led to scale from that first Kafka topic that we created to be able to go and not just listen to EtherDelta, but to all the other exchanges, right? IDEX and all these other ones that keep coming up. And for every single one of these, we ended up doing these Python virtual environments because the modules that you're actually installing via pip, some of these will be some GitHub project with 10 commits that you don't really want running next to your secured environments that actually have access to your wallets. Right? So for some of these exchanges, they'll have these, what is it? Hexbytes is a perfect example. It's actually incorporated into the Ethereum Web3 APIs now. But the project came from one developer with some 10 commits. And not hating on Hexbytes, but it's not really the kind of code that you want running next to your secured financial infra. So we're going to go into the demo about what that actually looks like. But I just wanted to start with the end in mind. Right? Once we actually got this data, what does it actually look like? And here's just one example where you can clearly see that the buyer address is the same as the seller address. And these are just essentially Ethereum addresses, and every single one of these transactions corresponds to 34 Ethereum that the user was buying his own coin. Now, the conversion ends up being somewhere around $15,000, and the price changes quite a bit with Ethereum, but that's, all those transaction hashes, you can actually go and verify them on the blockchain yourself. These are the same person executing his own buy and sell. So now we're actually going to go into the demo of how we got here, and what does it actually look like to connect to the blockchain. So here's our notebooks, and I'm just going to start with the first producer. So nothing too exciting, just a quick mention on using Spark Magic and Livy to create this session with these virtual environments remotely. Both of them open source, great tools if you want to go contribute to them, incredibly useful. But I'm going to kind of skip over the high-level one and just go straight into what does it actually look like to connect to the blockchain. So this is running on that Geth node that Kat mentioned, right? That 2 gig tiny node is running a Docker container. And that Docker container is just running Parity, which is one of the Ethereum clients for actually retrieving data from live peers. So I'm not sure if you can actually see the block number here. But if I actually run this, you'll see that this is actually connected live to the blockchain, right? And there's a new block discovered every 5 to 15 seconds. So if I run this a couple times, we should see the block increment to 71. And 5 to 15 seconds. Looks like I got the upward of 15. Block. There we go. All right, so we're actually connected live to the blockchain. This is getting live data from all the peers. It's not mining, and that's the key thing to differentiate with your IT department. Because I think I've been in a bit of trouble at IBM for running these kind of data analytics, because it'll trigger a lot of the same alarms that mining does, but really you're only connecting to the peers and retrieving the data live. So once we have that data, we have to go in here and write a couple methods to actually cleanse the data, right? Like any other pipeline, the data that you get back is dirty. And it has a lot of these nested attribute dictionaries. It has these hex bytes data types. So that was kind of the motivator for actually doing this in these remote notebooks so that we could actually massage the data before we were able to actually take a clean JSON and put it over into Kafka. So for this first one, we're actually just creating a producer with 3 brokers. And let me come down here and actually just kick off the producer. All right, so this one's not too exciting. It's just letting us know, hey, I have a new block. This block has these many transactions that actually executed logs on the smart contracts. But it works quite well, so I'm going to just kick that one off. And now I'm going to go into the ED processor. And the ED processor is the second one that actually takes those new blocks. It filters for the ones that got posted to the EtherDelta address, the ones that got sent to that smart contract. And then it's going to go in there and it's going to do that ETL. It's going to figure out where was the buyer equal to the seller. Sounds pretty simple, right? So again, same kind of concept, Spark Magic, creating a notebook. But let me come down here, and this one should be connected, and I shouldn't see 71 anymore. 76. Right, so a couple kind of key things here, right? The EtherDelta contract address, this is essentially the URL that people are posting to when they're executing a command. Now, for end users, they don't really interact with it in this way. They interact with it via some UI, and the most popular one is EtherDelta, which is actually hosted as a GitHub page. But they'll go in there and they'll issue buys and sells, and under the covers, that GitHub project is actually executing transactions to this EtherDelta contract address. So I'm going to come in here now and just kick off the, or not kick off, and I'm actually going to show you, once we get the data, right, what are we actually talking about for that consumer where the args is equal to, or the args get is equal to the args give. Right, so to get here was kind of a couple extra steps. We had to do some of that data massaging. We had to create that first topic. We had to come in here and essentially create a new consumer where we're just picking up every new message that gets created, if I find my cursor. Right, so we're actually listening to the first topic we created. Every time that gets a new message, we're just coming in here. We're verifying that the EtherDelta trade method was the one that was actually getting executed. And within that trade, within only the EtherDelta addresses, now we're doing that filter for get equals give. So once you get it to this level, yeah, that's pretty cool, right? And I was running this earlier, and it looks like somebody was pretty busy today, right? This is all producing those buyer equals seller. So let's kind of jump over now and take a look. And again, this is just data massaging, not too exciting, but I would want to get down to where we're actually finding, using just data frames to visualize it a little better. Now, remember how I mentioned that the fees for the exchange are paid in SHT? That was the key thing for these scammers being able to do this profitably. So somebody today actually messed up, and they executed on the wrong side. So there was 3 trades where they were actually paying the fees with Ethereum. So these people actually lost a couple $100 in, I guess, testing their bots, but they did it on the wrong side of the market. They were still new to this. When you're doing it from the other side, the one that we're actually catching, this is where you really start getting some pretty interesting stuff, right? And I'll highlight this one and just do a find so you can kind of see. And holy crap, this guy was pretty busy, right? He's been executing these trades over and over again. And if I scroll to the right, so he's doing it for, what is that, 52 Ethereum. 52 Ethereum was his highest trade, right? So he's doing like $25,000 transactions today. This is all live data from today. And you can see that he was pretty busy, but somebody else was coming in here and kind of challenging him on, well, maybe they were doing it for a different coin. Right? So if I'm just doing a basic find, same concept, right? Buyer equals seller. This person wasn't so busy. They only did four trades. Probably another person testing out their bots today. So let's kind of go back and figure out, who have we caught and how much money are they actually making, right? It's nice that they're doing this over and over again, but there's the so what factor. So this is kind of our SHT coin of the month. And we ended up tracking it down by just taking one of those addresses and going back to the blockchain and trying to figure out, what did this person do? How did they do it? So this particular coin, ADU coin. So there was a person, or bot probably, that came in here and created ADU coin. They created it with 110 billion tokens supply. And these 110 billion tokens were essentially worthless, right? He literally just created them. And this one was particularly interesting because he created the coin 90 days ago. It got listed to the exchanges a week ago. So for 90 days, he was trying to get his token listed on the exchanges, right? Because it doesn't just get listed automatically. You have to issue a pull request on that github.io page. You have to wait for them to accept it, or realistically bribe them. And 90 days later, he was able to list ADU coin on EtherDelta. And what we ended up seeing, and it's a bit hard to see on the right-hand side, but every single one of those trades, he was doing it for essentially 50 Ethereum, right? So that's like $21,000 that he was buying his own coin over and over again. And each time, he was selling himself 16.7 million ADUs. And you can see the volume on the right. All those transactions that are kind of highlighted, those 50.1 Ethereum, he was actually quite effective at doing this. But the second question is, so what? How much money did he actually make? And I put a link here, and this is all going to be public. Anyone can go on there and actually see these trades happening. Now you actually know what's happening under the covers. So what we ended up seeing is that bots and a lot of the other websites now believe that he has $11.8 million, of which 11.7 comes from the ADU. So this person, this individual, when I queried his wallet, he actually had 36 Ethereum. Ethereum, you can consider one of the more real currencies. It's actually in use. So he actually had quite a bit of money, right? That's like, what, $22,000? But the bulk of his money, that $11.7 million, came from ADU. And this was tricking other new investors. It was tricking bots. And what we see on the right-hand side is that over 100 people actually fell for this scam. And when we went in there, I mean, these are ranging from like $100 to I think the highest one was 4 Ethereum, like $2,000 that somebody lost buying these worthless ADU coins. And what was fascinating is that, he does this over a given amount of time, but essentially within 3 days, the coin was dead. There was no more volume. He pulled out. He had already cashed in his scam and tricked over 100 people. All those 100 are now holding this SHT coin, which is ADU. And, well, that's essentially it, right? He's selling and profiting over and over again.
So we found the next steps are up to you. We found the Twitter bot to be a little bit too risky, but all of the codes that we are using is open source, so you can click on the link and check out the GitHub demos. So outside of how to build your own shitcoin, any questions?
Do you find that anybody has tried setting up multiple accounts and then bouncing between them?
That's a really good question, and you'll see that a lot more on some of the newer exchanges like IDEX. They'll get a little bit more creative. We wanted to stick to just the basic buyer equals seller for this talk, but yeah, it's a great question. And once you have it in a data frame, you can go and do that kind of analysis. And that was one of the reasons to bring this data to the data warehouse instead of trying to query it directly from the blockchain. But absolutely.
So that the company that did their presentation yesterday with the wine distribution, they're doing blockchain, but obviously they have their own internal exchange. Is that correct? So they're managing the whole thing, and the people that are exchanging, if you will, are just the consumer and the supplier.
So the one yesterday was driving it more as a smart contract. So if I kind of just skip back to that smart contract one real quick. Right, so essentially the company yesterday had created their own smart contract where it wasn't really an exchange, but it was more just a method that you could go and pass in some input data and have that data persisted to the blockchain. So the company yesterday was doing off-chain and on-chain. All of what we showed here is all on-chain, events that actually get stored to the public ledger.
Well, I guess my question is there a public ledger?
For them, yeah. So they were actually using, I think they mentioned they were partially on Ethereum and partially on Hyperledger.
Yeah, there's lots of applications that we can do here. We just did the first one as a proof of concept because we're mostly doing this in the middle of the night on our own time. There's lots of interesting applications that we could find out of exactly what you've said, basically figuring out who is actually behind the wallets on different exchanges. Other use cases could be, for example, looking at the coins that have most of their, over 90% of their holders concentrated in one person's wallet. So there's lots of things we can detect here.
Cool. I think that was...
OK. Well, if you're one of those 110 people, try to get out before the other 109 figure it out. Thank you guys for your attention.